Okay, what we're going to be looking at today is a little bit of dividing fractions. And we do a process called, where we change it to a multiplication problem, and we flip the fraction after the division sign. So, that's called multiplicative inverse is what we're doing when we do that. And the first part of this lesson is going to be just writing fractions as multiplicative inverses. So here's the way that this works. So if we have a negative 4/5 for a fraction, the multiplicative inverse would be just flipping it. Okay, so this would be negative 5/4. Okay, that would be the multiplicative inverse of the fraction negative 4/5. Here now we have a mixed number. So we would make it improper first, and then we would flip it. So to make it improper, we go times plus. So 48 and 1 is 49, so it's equal to 49/8. Now we flip it. So the multiplicative inverse is 8/49. So in other words, if you were doing a division problem and you changed the division sign to multiplication, the very next fraction has to be flipped, okay, and then you multiply. So that's the process with that. Okay, let's go ahead and do one now. Okay, here is a negative divided by a positive. So the same rules apply that would for integers. And a negative divided by a positive is a negative answer here. So we do got to remember that in the process of solving this problem. Okay, so what we're going to do is this negative 1/8 stays. We don't mess with that. Okay, but we're going to rewrite it as a multiplication problem. I'm going to use a dot for multiply, and I flip 2/5 to 5/2. Okay, when I was a math student, probably 7th or 8th grade, I had a teacher teach me a little trick where a little poem that went, "Don't bother to ask what and why, flip the sucker and multiply." And that's a catchy little thing to remember what you do when you're dividing fractions. You flip it and multiply. So now we have a multiplication problem. When we've been doing multiplication problems, this is something students should be able to do. We look for any cross-reducing that we can do, any reducing with any top to bottom number. Nothing that we can do, so we just go ahead and multiply our numerators. This is going to be a negative answer, so we get 5, and we multiply our denominators, we get 16. So our answer is negative 5/16. Okay, here's one that's certainly a little more challenging. Okay, now we have two mixed numbers. You're going to notice a set of parentheses here. Okay, that is nothing more than a set of parentheses to help keep the problem neat. It really means nothing in doing that part first or anything like that. It's just to keep the problem neat because you have a division sign, and they don't want you to confuse this with a subtraction sign. This is negative 2 2/5. So we make them improper first. So that's the first step in solving this problem. So 53/5, so negative 53/5. Okay, I'm going to still keep it division until I get this done. 12, so negative 12/5. Okay, I made them both improper. Now we got a negative divided by a negative, so our answer is going to be positive. That's the rule when you have two negatives. So in this case here now we're going to rewrite it as a multiplication problem. This first fraction stays. Now we change the division to multiplication, and here is where we flip the multiplicative inverse. So this becomes negative 5/12. Okay, now it's just a matter of multiplying. Okay, we can do some cross-reducing here. 5 goes into 5 once, 5 goes into 5 once. Okay, no reducing this way or any other reducing here. So we end up with 53/12. Okay, now it is positive because we have a negative times a negative. Now this we can't leave like this. We have to make it improper. Okay, so once again we have 53/12 for our answer, and we have to make this a mixed number. This is improper. We got to change it to a mixed number. Okay, so what we're doing when we do that is we're actually doing a little division problem. Now, some students can do this in their head, okay, some have to actually set it up. All right, so it's gonna go in 4 times, we get 48. I subtract here, I get 5. I take that remainder and I put it over the 12. Okay, so I end up with 4 and 5/12 for my answer. Okay, now, here's another process in doing these where we have some variables involved. The book is not going to give what the variables are either. Okay, they want the problem simplified. In other words, get it in the simplest form as possible. Solve it as far as you can. Okay, when there's variables involved, there's only so far that you can go unless you know what the variables actually are. So in this case here, we're going to rewrite it as a multiplication problem. So we change the division to multiplication, and we flip. Remember, that's called the multiplicative inverse. Okay, now we can go ahead and solve this here, and we can do some reducing, some cross-reducing, or any reducing with any numerator and any denominator. But we can't do anything this way, we got to go this way because that's just the way it works out on this problem. Okay, 3 goes into 3 once, goes into 6 twice, and we can take care of the ends as well. They're canceled out. Okay, now this is like having a 1m here and a 7m. Well, the m's can take care of one another. This m can cancel out this m, even though this is already reduced 1/7. We can't reduce that down any further. But an m up in the numerator can cancel out an m down in the denominator. Okay, so there's what we're left with. Now we can go ahead and do the multiplying. So 1 times 1 is 1, and 2 times 7 is 14. So the answer to this problem right here is 1/14. We were able to cancel out all the variables.